Good afternoon. I'm Amanda Brock. I'm the CEO at Open UK. It's a great pleasure to welcome you along to today's State of Open Subset talk. This week, we're having episode 7, and we're welcoming Andrew Williams, the CEO of Fine Labs, based up in Scotland, to join us today. And Andrew is going to talk to us about Fine and Go, about native graphical apps for all platforms with a single code base. He's going to join us in a moment to share his discussion, and you're very welcome to join us and to chat along as he is presenting to you, and there'll be a live Q&A at the end of the session. Also, if you would like to watch the session or any other session after today, you're very welcome to do that on YouTube, and you'll find them all on our website at openuk/subset. And of course, all of the topics that we're covering in State of Open Subset come from our conference, State of OpenCon. And the next one of those will take place in January, February next year as part of the FOSDEM Fringe. So with that, I would like to hand you over to Andrew Williams, CEO at Fine Labs, a long-term contributor to open source, an Apache committer, and a board director at Scotland Is. Andrew, welcome.
Hi, everyone. Thanks for joining me at State of Open Subset. It's a real honour to be presenting to you today. Thanks so much for joining me. I hope that you enjoy what I would like to present today about how open source is making it possible to build an exciting new future for app development. But first, if you'll indulge me, a little bit about myself. I am a software engineer, have been for, I think, 20 years now. And an author writing about generally the topics that I'm coding around. I've been in open source ecosystem for 25 years, I think, and definitely an advocate for all of the things that it enables. I've been a Go developer since 2018 when I started the Fine Toolkit, and that has been really my passion and my focus ever since. I am also the CEO at Fine Labs, where we promote the benefits of platform-agnostic app development and, of course, open source and all that it enables. Outside of work, I have a few interests as well. I do quite enjoy trains. This is me in the garden. I also love a bit of music. This was a fantastic opportunity to see the soundtrack of Zelda played live. And sci-fi as well. It's just a great mix of things there. Of course, the next step in most presentations would be to ask DALL-E to create an image that combines all of those things. But I didn't have to. Disney World is the place to go for all of those things. I think it's probably my happiest place on earth. But of course, that's a bit random. What links all of this to open source? Well, I think it's the community. The Disney cast members, if you've ever been, are a fantastic group who work really well together to deliver a phenomenal experience. They are a fantastic community, and it's really them that makes the entire place possible. And I think that describes very well also the open source community and the community around the Go programming language. So, segue done. Why on earth would we build an open source native app toolkit? There's obviously many different ways to build applications, but this, to me, was a great chance for a fresh start, a chance to put aside the legacy challenges of outdated toolkits. They have done fantastic service, but they were, let's face it, built 25, maybe even 30 years ago on the technologies that were cutting edge at the time. They have adapted well, but there are definitely great leverages in picking new technologies and techniques. It's an opportunity to have something that is far easier to understand. Being fully open gives us the opportunity for people to understand the code, see how it works, and contribute as well. With every item of source code available, from the widget set all the way down to the drivers, folk can really get into it at any level. It enables us to build platform-independent native apps, or platform-agnostic, actually, as we're aiming for, the ability to build a native app without worrying about the platform that it might be running on. We can compile for absolutely any device, And that means that you don't have to worry about the toolchain for specific platforms. You can build in your own IDE in your preferred manner and target all of these systems. It also gives us an opportunity to have a lightweight solution with great performance. The legacy that is associated with previous toolkits has made development a little bit slower, and sometimes the app's a bit slower as well. And linking in libraries that make it all possible can add overhead and also set up challenges. So there's an opportunity to really be as lean as possible and offer great performance, not just on mobiles and desktops, but all the way down to embedded devices, Raspberry Pis, or screens that you see, signage in an airport or kiosks in your local store. And we have the opportunity to be community driven. The contributions and support that are available in the open is always so much better than those for proprietary solutions. And it gives us an opportunity to really focus on what developers need, not just what we think that they would like to be building with. So that's why we would build a toolkit, but why pick the Go programming language? It's one that people are not quite so familiar with. But it is quoted as one of those languages that most people would like to learn. I picked it up because it offers so many fantastic benefits that were going to be useful in developing a project like Fine. The applications that we compile are written just once, and they can be built to run on any device. So out of the box, we've got a really big benefit there. And like I mentioned before, it's really important that there's no libraries to be installed. There's no setup for our end users. These applications are just going to work, portable onto any device and run with no dependencies. That means that the development work that we put in the compilation and the hard problems that are solved in the toolkit mean that it's much better for the end user experience as well as developers. And that gives us native performance. And also, we don't have to have the duplicate code associated with targeting different native platforms with different code bases. Even the best attempts to have real shared code across mobile or desktop applications have not necessarily hit the nail particularly well. So we are one code base top to bottom. And Go comes, if you don't know, with fantastic standards, language techniques, and general best principles. By following these, you've got application software that's really easy to read, anybody can pick up and understand and build on going forward, which I think is really lowering the barrier of entry to building graphical apps natively across all platforms. And so that takes us to the Fine project, which I'm going to be telling you a lot about today. Fine has the ambition to be the simplest toolkit for building beautiful and usable native graphical applications that work on desktop, mobile, web, and all sorts of other interesting device categories as well. We have been in development for over 5 years now, and we're getting really close to really delivering on that ambition. For people who are not too familiar with the landscape as well, I've got this graph of the Stargazer totals for Go-based native toolkits. And Fine here is really getting on something. The popularity has shot up so much. It's behind the legend, I suppose, on this generated graph. But hopefully that shows well that people are really finding this a productive and interesting platform to be using. But let me talk more about the specifics. How can you use this to build an application that's going to work on all these devices? So let's step into our very first app. This is my friend Gofi. He is the mascot for the Go programming language. You'll see a few more photos of gophers. Although, disclaimer, I don't know if every single one of them is a gopher, so feel free to point that out later if you'd like. This one definitely is. He is my friend and my coding mentor when I'm working from home. So let's get started with some setup to build our first app. There are a couple of prerequisites, as you might expect. We're going to need a working Go compiler. The install is pretty set up. Just go to go.dev and follow the instructions if you haven't before, or use your preferred package manager. You're going to need at least version 1.14, although we are looking at upgrading the version necessary at some point this year to get more of the modern language benefits into the toolkit. Because we are working with native graphical context, the hardware acceleration offered by your OS driver, we're going to need some C compiled under the hood. Don't worry, you're never going to need to touch any C code yourself, but the compiler needs to be present for this to work. A lot of developers would, of course, already have that set up. And again, on BSD or Linux, your package manager will help. If you're on macOS, then Xcode will install everything that you need. Windows can be a little bit fiddly. MSys2 is what we would recommend, although TDM GCC works and various others do too. And for Android development, you'll need the appropriate tools like Android Studio installed as well. There's a whole lot more detailed setup information, if you would like, on the website, which I'll share with you later in this presentation. So how do you get set up? Well, here's the steps that you'll need. We have to create a project directory for our new piece of code. We'll move into that project directory and initialize the Go module. And then we get the Find library installed onto our system with the go get command there, find.io/find/v2 at latest. And then we can edit our first Go code. It's pretty straightforward, and here's what the code is going to look like. So if you've ever done Go before, this would be very familiar. If not, let me just run through very briefly what we have here. There is the main package declaration. We do that because we're building an executable package. We then import the two most important packages from the Find library, the app package, which is the runtime setup and your OS-specific code that's going to get your application up and running in the right way for the target platform. And the widget library, which is where all of the standard widgets are located. You'll use that a lot in putting together your application. We then open a main function. This is the entry point into any executable Go app. We create a new application, assign that to variable A because it's pretty clear what that's going to be doing, and then a new window from the application. We'll call it hello. That is going to appear on some systems like a desktop when you have a window border with the title in it. So pick something suitable. And then we set the content of the window. In this example, a very simple label using the content hello fine will be displayed in the content area. And then we just call show and run for the window, which is a shortcut for showing the window and running the application. You can have lots of different windows open, and they can open and close through the life cycle of your application, but you only run it once. So this is just a helper to get that set up. Once we've written that code, it's as simple as go run, and we will have our application building, and it will appear on screen. This should be fairly fast for most computers, but I'm aware that compiling the C code in the background on Windows can be a little bit slow. So give it a couple of minutes, or maybe make a cup of tea just this first time. And when you get back, we will have a little window like this. Hello, fine. You can see there it is a light background. It matches to some extent the window border. If your operating system was set for dark mode, then it would be a dark gray background with lighter text. It's picking up the user configuration and adapting the application appropriately. So there we go. It's your first application. However, this gopher, he expected a little bit more. Maybe we can build something rather more impressive with the time that we've got today. Well, absolutely. Let's do that. Let's set up instead a text editor. So to do that, there's obviously a lot in this screen, but don't worry. We're going to step through every item of that. And before the end of this presentation, we'll have a working text editor on multiple devices. So you can see we have a toolbar at the top with some common functionality. There is an editor widget in the middle, which is going to be your main text entry. And I've put a status bar footer there, which is indicating where the cursor position is. Of course, many things could be added there. Use your imagination, I suppose. But I just wanted to show a few features. So I'll show you the code here necessary to get it set up. Once again, we need our main function, and you'll see a lot of similarities there. In this case, we're not currently using the widget toolkit because I've moved that into a separate function. What we're doing is setting up an application and a window, this time with the label text edit. And I am calling a new function, which we'll see in a moment, called MakeUI. That's constructing the user interface, and we're passing that into setContent. And because this application should be larger than the minimum necessary to display the window, we're going to set a preferred size using window.resize. This is going to be a best efforts approach on the operating system. It will adapt appropriately, obviously, on a mobile device that's going to be full screen by default, so you will get the size of the screen. But in a multi-window desktop sort of scenario, that's the platform-independent sizing that will be applied. To some extent, you may just need to try some numbers there and see what works for your application, because a window is going to be the minimum size by default. That's how Fine packs the widgets in. So let's use some standard widgets and put together the user interface. This is the MakeUI function that is setting up our content. It's returning a canvas object because everything that can be visualized on screen is a canvas object. Interactive items or widgets, but we also can display raw canvas items like lines, text, circles, and those are also canvas objects. They're not interactive, so they just implement the interface directly. In this code, we are setting up an entry, a multi-line entry, in fact, that will fill the space in the middle. We are then setting up two labels, each containing the number 1 to start with, and assigning them to the fields cursor row and cursor column. And that is the interactive elements set up. The toolbar will then create in a separate function, and later on we'll put them together at the end of the function. But just to break it down a little bit more, let's have a look at the toolbar function. So this toolbar, build toolbar function is just exactly doing that, building a new toolbar object. We could have said it was returning a Fine canvas object as well, because a widget toolbar is exactly that. And as you can see, we're simply setting on one line per action the icon that we will use to demonstrate it, and then what the action is. Now, these open, save, cut, copy, paste are the names of functions, because Go gives us the great opportunity to pass functions by name, and so those will be invoked when the action is tapped in the toolbar. Now, let's look at the rest of the user interface setup. This is where we introduce containers. So a container is another really important type of canvas object. It allows us to put multiple child items together in one area. And how that works is defined by the layout. The container package contains lots of helpful layouts. Here, you can see we're using HBox. That's a horizontal box, and it will pack things left to right in the minimum width possible. So in this case, we have the cursor row, and then the label for that number, the text col, and then the label for the cursor column number. And before that, we have a spacer packed in, which means that it's going to right align everything because the layout spacer is going to fill the space available on the left. And then we return another container. This time it is a border container, which is super helpful for laying out applications. They take the parameter of top, bottom, left and right, and anything else is the content. So here you can see we set the toolbar at the top, the status bar that we just defined as a container at the bottom. The left and right are nothing, so we just pass nil. And then we put our entry into a new scroll container. That's everything. If you then issue a Go run for the file that we just created, you will see an application window very much like this one here. Wow, that is our GUI done. Well, that was pretty easy. But before we get into the logic, we could see how that might appear on a different device. Stepping ahead a little bit, I loaded this up onto my iPhone. And with no extra code, no configuration required. This was the screen that I was greeted with. It is our text editor adapting to the screen size and setup of a mobile phone. So there we have the basic graphical interface. But we're not done. Really, you want to be able to open and save, like we added to the toolbar. So let's look at that. Now, file and input output is a little bit complicated when you're going to any type of device. For one thing, if you've ever tried mobile development, you'll know that sandboxing of applications makes it a little bit difficult. You don't really have access to the entire file system. You can't make certain assumptions. And when you're opening a file, it might not even be a file. Thankfully, Fine has an abstraction layer that takes care of this for you. So we have our file open dialog, which looks something like on screen, which is going to vary depending on your system. But let's have a quick look at how that code works. So this is our open method. You might notice the name matches what the toolbar referenced before. This function will be called when we tap on that toolbar item. So we're using a dialog package here, which has a few other helpful ways to have things presented to the user. Initially, we're going to ask for a file open dialog to be shown. Now, this takes a function parameter that will be used as a callback internally. It will get called when the user has made their choice and will be passed a URI read closer. Now, this is a read-only stream to a data source identified by a URI. That's a unique resource identifier. It sounds like some complicated terminology here, but basically, it's like working with a file. You're going to be given access to its data stream. And we are passed an error because there may have been a problem. On the third line here, you can see we look at that error. And if there was a problem, we don't really know in this example what to do about it. So we're using another dialog helper method, show error. And that is simply going to present an error dialog in the current window that we're passing. And we'll return then. The user will have been told that something went wrong and they might try again later. We then check to see if the data source is nil. If the user cancelled, we still want to know that they made a choice, but their choice is the empty choice, so we won't progress because they decided not to open a file. Then we get into the reading of the data. You can see here we've used the IOUtil package to read all out of the stream. So now we have the data in memory. If an error occurs, then we'll do basically the same as before, but we want to show the error if there was an error. If there wasn't, we're going to go on the happy path, and we're going to first close this data stream, always a good idea. And then we'll set the text on our editor, the entry widget that we set up, to the content of the data. We have the bytes in memory, so we'll make that a string and simply set the content. And then we're going to save the URI. Here you can see we're asking the resource where it was coming from. The resource identifier will know this. We saved that for later because we might want to be able to write back. That won't always be possible. Like I said, sometimes the data could be coming from not a file source, and it's entirely possible that something unexpected might go in there, but we're going to do our best efforts, so we'll remember where it came from. And all of that is, like the other dialogues, told which window to present in. Because it's great on lots of different platforms to not have too many windows open. Dialogues and Fine open in the current window. That's just the way that it's set up, so we tell it which window to open in. If you didn't like that, you could open a new window for a dialogue, but we just find that it's better when you're working within the current space. So that's how we open a file. It's pretty straightforward once you understand the abstraction that we have. We can also save to a file in a similar sort of a way. We'll use the file save dialog, which is very similar to the file open. This time we're given a write stream so that we can push the data out into it. We're going to check for errors, check for the empty selection, but assuming that goes well, we will simply write the contents of our entries text into that write stream and close it when we're done, showing an error along the way if there was a problem. So that's save as. It's pretty straightforward. But what we are often going to want to do is to save the current file where it is. So we want that save method as well. And that's the last one here, the last big chunk of code. We are going to check if we know where the file came from. And that's where the saved URI comes in. If we do, then we're able to ask the storage abstraction in Fine to be able to open a writer to that location. And so at that point, we're asking if the sandbox will allow us permission to write back. And if there is an error there, we're going to have to tell the user and bail. But assuming there wasn't, then we're going to write it out. And again, show an error dialog if anything went wrong. Now, that is, I suppose, a fair amount to talk through just for reading and writing files. But like I said, we don't know that they're files. It's possible for this data to come from anywhere. And let me show what that really means. If we ran this code on your laptop, it would do exactly what you think, show you access to the file system, open and save wherever you're looking for. But then you can run exactly the same code on your mobile device. Here it is running on my iPhone. Now that is obviously a very different file dialog. This in fact is opening up my iCloud drive because I have an Apple subscription. So I could open data that's coming from the cloud. Similarly, I could connect to my Dropbox account or something like that, and the data would be streamed into my application from a remote source that is not a local file. Sometimes writing back to that file is going to work, and sometimes it might not be, so we need to be careful to check for errors. But you can see why it's important that we have these abstractions in place, because it means that this code is going to work on absolutely any device without any modifications. That's why we talk about platform agnostic, because the code, once written, is going to compile and run on all these different types of app configurations. Now, that's our data open and writing as well. But there's a little bit more. The status bar at the bottom wasn't updated by what we did. So we set up some callbacks that are going to make sure that that is up to date. When we want to update the status bar, we're going to call this function update status. Inside that, we're going to set the text on our cursor row and cursor call labels. And the information that we're going to use is the current cursor row and column for our entry. Actually, we're going to add 1 to both of them because users are typically expecting a 1 index representation, but internally, as you might expect, it's going to be a 0 offset. And then we update our makeUI function. We just insert one new line, entry.onCursorChanged equals update status. And once again, we're making use here of the trick that we can pass functions around by their name. So now, when the cursor moves inside the entry that we have defined, it's going to call update status. And that update status function is going to update the text shown in our status bar. And there we have it, the whole life cycle. We've got the ability to show the UI on any platform, edit the text, open a file if we want to, and write out to other data sources too. And the UI is going to update appropriately at all times. We haven't had to think too much about memory allocation, how the object lifecycle occurs, or the threading model involved. All of those things have been absolutely taken care of under the hood. Of course, there is a whole lot more that you could do with this application. The possibilities, I mean, essentially, they're endless depending on your imagination. But let's think about the types of things that a user might expect from a text editor. We could have set the main menu on the window to provide a lot more functionality. That's going to be included in the standard widget library. In fact, you set the menu metadata on your application, and then it's the driver that will render it in the right way. So on, for example, a Windows application, you will have a menu bar inserted into the window that you're viewing. On macOS, it will appear in the system menu bar at the top of the screen. And on mobile devices, it's typically going to render a burger side entry style of menu so that the same content is there, but it's not taking up any of your screen. There are also somewhat platform-specific bits of functionality available. So the second item here, the desktop application can have a system tray menu appear in whatever the standard area is for the platform that your user is running on. That's declared as a desktop-specific addition to the application interface. So we would check using type assertion if our application is a desktop application, which we'll learn at runtime. And in the standard Go type checking way, we would then use the cast class to access the functionality specific to desktops, which is, it can seem a little bit peculiar, but it means that you've got still a fully typed system. Your IDE is going to be able to autocomplete, and you don't have to do anything peculiar wiring things up. You just need a runtime type assertion, and that's going to set everything up for you. We could also use data binding. There's a whole other package in the Find toolkit for wiring together data sources and widgets. So we could have set up our status bar as a data binding between the cursor position and the label. Also, you could have the edited state be a Boolean in memory that is updated when the user edits to say that it's changed. And then that when they save, it could say, well, okay, there's no changes anymore. And using data binding, we could update, for example, the title of the window to add an asterisk at the end. So there's a lot you can do there with data binding as well. And it's able to avoid quite a bit of the manual coding that you might be doing otherwise. Obviously, with a limited time, there's not the possibility to talk about all of the different widgets, the capabilities, and everything that you can do with the Find toolkit, everything that comes bundled, but you can try it on your local machine with Go install and the path find.io/find/v2/cmd/find_demo at latest. That's going to put the find demo command onto your computer, and you can run it and see everything that's possible. Actually, just recently we uploaded to the web as well. So you can go to demo.find.io in a web browser and see it running locally where most of the functionality is available without having to install it. Let me just move on now to testing and distribution. Our Gophers have something that they've created, but they want to make sure that the product is good and then share it with their friends. So Go has a fantastic unit testing framework built right in, and the coverage of most libraries is really excellent. So we wanted to make sure the same thing was possible with Fine, and so people would then no longer be able to say, oh, well, unit testing a graphical application is really difficult, so we're not including that. That's not true anymore. We absolutely can unit test every aspect of an application built with Fine. So here you can see we have a test text selected function. And that is creating a new entry in memory. And we are simulating typing of the word hello into that entry. And then we use the excellent Testify package to assert that the content, the text of that entry is indeed hello. That test, of course, is going to pass. Then we can use the test package again to simulate a double tap. And we are then able to check that the selected text is hello as well. So we can therefore test that the front end is going to render the selection across the word hello. And we can check that the cursor has progressed to the end of the selected area. And that can be run as a unit test. Let me just show you here. We've edited the code, and then we just run it with Go test. And the great thing about this is that the unit testing framework is going to do all of that in memory. There's not going to be a window appear on your screen. It's not going to take control of your mouse or keyboard to run this. And as a result, it runs super fast. So you can have thousands of these tests in your application, validating the behavior of the code that you have built. So we have an application and it's well tested, and we would love to get it out to other people. So far, we have just installed it locally. So far, we have just been editing the files and running them from the command line like any other Go application. But we can package them up into a graphical package like any other. So we will use the Fine helper tool here, command line assistant, that's part of the project you can get with that install command, and then use it to package our application. find package will bundle up the code into a package for your current operating system. Or if you want to target a different one, we could pass an OS parameter. So on our Mac, we could package up for Linux using find package-os Linux. That gives you a testing bundle, something that you can share with your friends, upload onto a website or send over for testing. But you may also want to install locally, like we have in the pictures on this slide. So we can use the same command. We can find install, and that is going to set it up in the current system. As you can see on the application search window, the light grey window on the right-hand side here. So it will then find my Find Settings application that I've just built because it has been installed into the Applications folder on a Mac. On Windows, this will set it up in your Start menu, and for Linux, that would be into probably, I think, use your local bin and a desktop file set into the standard app discovery path. But like the package command, we can install onto a different target system. So here I've issued the find install-os iOS, and that has sent the application onto my iPhone. There are some complexities there because to be able to do that, you need an Apple account and the provisioning profile and signature from Apple. There's a lot of documentation, again, online, and in fact, the find command is going to do its best to prompt you for missing information so that you can set up. But it really should be that straightforward once the tools are set up. And of course, you could do the same for your Android device as well. For distribution, we have an additional step called release. And so the package command, that builds an application bundle that installs well locally or can be used for beta testing, I suppose. But when you're releasing to a store, for example, you're probably going to need a little bit more metadata so they could be uniquely identified. So we have the release command, and it takes a few extra parameters like the app ID. When you're packaging for the App Store on iOS, of course, you're going to need this information along with the proof that you're the right developer. So we have the profile and certificate parameters, and Android would pass a key store. This is getting to be quite a lot to remember, though. So we have introduced a metadata file called fineapp.toml that's going to take care of this, give you a more reproducible build as well. So as you might imagine, it's a simple markup file. And this is just an example for the Find Demo application. We have an icon file, we give it a name and an ID, and also the version number. These versions will increment automatically when you release, and the rest of the metadata is saving to avoid the keystrokes or remembering the parameters to be passed so that your application bundle always includes the icon, the metadata, so that it is recognized by the target system and familiar to your users. So we can get applications out into the wild. They could be distributed to your friends or onto the stores. So in my remaining few minutes, I just wanted to show you a little bit of some applications that can be found out there already. We have actually a website set up at apps.find.io that has a really great selection of applications. And here's a pic of a couple of my favorites. This is a Markdown editor. Fully functional. It uses the built-in Markdown capabilities of the rich text widget in the toolkit. And it uses very simple callback so that when the entry is edited, the rich text updates. And the application that you see there is only about 12 or less than 20 lines of code. So that's just an example of something out of the box that can be done. Roomport is an excellent file sharing application on the Just Boolean protocol, I think. And here you see somebody's able to keep track of the files that they're sharing across their network with a very elegant user interface. And this is a media player by one of the team as well, who put together a fair number of custom widgets to create something reminiscent of a familiar music player that I probably shouldn't name. Somebody out in the community made this excellent Wordle clone. I played that far too much when they showed us that it was available. And sticking with the theme of cross-platform, this is a chat application that works for lots of different server types. So Discord and Telegram and WhatsApp all connected there on one system. And that is just showing that you can plug in lots of different items in the back and still have a front end that summarizes and interacts with them all really well. And also in a slightly different space, there is this medical imaging viewer application that was put together, I think, over a weekend of coding just to show what was possible with open source tools, but sitting on top of a Raspberry Pi with a very cheap touchscreen interface. And that's giving functionality to potentially doctors on the go. They could have the same thing running on their mobile phone, all with free and open source software. So quite a change to what they're used to. In fact, if you go to that website there are over 75 other applications fully open source where you can see what people have done and how they've done it to be inspired for your application. But not to forget, of course, if you are building a toolkit, you should be building a desktop environment. And so that's absolutely what we have done. FineDesk is a Linux and BSD desktop environment that will run all of the Fine applications, but of course anything else as well. Here is a screenshot running FineTerm and also our apps installer. So you've got a full desktop experience there. Again, the light dark mode, scaling, all of the benefits of a modern toolkit and fully vector based. So on a high resolution screen, you're going to get the excellent text rendering that you would expect from modern hardware. And naturally, you would need a login manager as well. So this is Fin, the Fine login system, which accompanies it quite nicely. So I hope that I have whetted your appetite for building applications that are going to compile and run natively on any system. If you would like to learn more, all of the documentation that I have mentioned is at the developer.fine.io website. There is a navigation on the left which should link you to anything that you want to know. If you prefer consuming videos, we have a YouTube channel with many tutorials. We share videos from the community as well. If you prefer a book, I have finished this packed title. It, I think, was released for 2.0, so some APIs that are missing, but it's all still completely relevant. We're backwards compatible to 2.0 completely. So you can check that out at your favorite bookstore if you would be interested. You can, of course, contribute to the project, and we would absolutely love it if you can, whether you're interested in doing a bit of coding, testing what we have, adding documentation, or really polishing the design with us. Please do get involved at the GitHub project. Or, of course, there are communities. We're part of the Gophers community on Slack and on Discord, and also on Matrix. So if any of those are places that you hang out, do come and say hi. There is usually a Fine channel, or you can hunt me down. And if you like the work that we are doing, of course, please do consider sponsoring us. The work that we do isn't possible without the community, but also it's not possible without our generous sponsors who we just can't thank enough. There's a list of a fantastic group of people who have helped us in various ways on that website as well. Thank you very much, everybody, for your time. I hope this has been interesting. I've enjoyed sharing what is possible using the Fine Toolkit, and it is fantastic to be part of this open source community. We, like I've said before, couldn't do what we do without the community, and it is a joy to be part of it. Thanks very much for having me today, and I hope that you enjoy the rest of the subset talks that are still to come. Have a great day.
Thanks, Andrew. I think everybody will agree that was really enlightening. Now, we would like to welcome you back next week to our next State of Open subset. And episode 8, the penultimate episode of this season, is a little bit unusual. And it's a little bit unusual because it has two presenters. We're absolutely delighted to have two of Open UK's ambassadors, Hannah Foxwell, the product director at SNCC, who's based in Yorkshire, and Adrian Mowat, technical community advocate for ChainGuard, who's also based up in Scotland. And actually, Adrian is going to be speaking live in Edinburgh on the 14th of September at our Open Technology for Sustainability Day. So thank you very much for your participation today. Please do catch up on any episodes you've missed on YouTube. You'll find them all at openuk.com/subset. and we look forward to seeing you another time. Take care.